Right, we're looking at polymers. Some of this like alkanes and alkenes and hydrocarbons, but we'll go for it. Right, can you remember what hydrocarbon is? Hydrocarbon is a molecule that contains hydrogen and carbon atoms only. So put all three parts in. A molecule that contains hydrogen and carbon atoms only. Right, we look at two groups here. The new. Right, they only contain two. Alkane and alkene. This is how I remember it. You've got one E, so it has a single carbon to carbon bond. Two E's, so it has a double carbon to carbon bond. Each carbon atom has 4 bonds. So 1, 2, 3, 4. Or you can have this situation. If you've got a double bond there, you're only allowed 1, 2 more, 1, 2 more. So each carbon has 4 bonds. When you attach to the end of these others, normally with a hydrocarbon, just stick a H on, don't leave it blank. Okay, so that's a H, H, H. Now, let's look at this. Let's just take this forward. Now, an alkane has the general formula CnH2n plus 2 and CnH2n. Right, I'll explain this in a second. This one's easier to explain because then the other ones. Right, if I've got C5, N is 5, so 2N will be 10, so it's H. 10, you just double the hydrogen. If I said to you C2, it would be H. 4. If I said C3, it would be H. 6. This is the easiest one to, I think, learn. And then if you know the alkene, you simply add 2. So if I said to you C4, I double the carbon, so it'll become C4H8, and then I add 2 more. 8 plus 2 is 10, so it'll be H10. So if I said C2, double that, it becomes 4, add 2 becomes 6. Let me do one more. If I said to you C5, it would be H 10 plus 2, which is 12. Right, done. What else do we need to know? Right, okay, just quickly. This is called a saturated compound because it contains only single carbon to carbon bonds. And this is unsaturated because it contains double carbon to carbon bonds. Right, let's move on. Right, so all that, you know all this stuff I've done on the side, you need to know all this. Let me just add one more thing. If you want to do a test for, oh my god, I can't spell anymore, for alkenes or unsaturated compounds, add, I've just learned this from the mark schemes, yeah, add orange bromine water, right, step 1, and then step 2, it will turn colorless. Don't put clear. If it will turn colorless if alkene is present. Right, leave it like that. Right, let's crack on with this. You're going to get a few typos in here, right, but we're not worried about that. Right, why is decane, this is a decane molecule here, why is that called a hydrocarbon? So what was the definition of hydrocarbon? It's there. We just put that there, yeah? Give the molecular formula of decane. Right, before we move forward, let us come down here. Right, there's different types of formula you need to know. You need to know displayed formula. You have molecular formula. That's short for formula. You have, okay, should we use, we'll leave this one here. It's structural formula, and you have something called empirical formula. Right, displayed formula would be something like this. Look, let's do this then. So I've got, we said we're going to stick hydrogens at the end of each of these. Let me just do it just so then it goes into your brain and my brain. Right, that's the displayed formula. Molecular formula tells you, right, I've got how many carbons? 1, 2, 3, 4. I've got 4 carbons. And I've got 2, 4, 6, 8, 9, 10 hydrogens. Structural formula, right? Okay, it's a bit more involved. So look at this bit here. I've got there a CH3. Then next to it, I've got a CH2 and another CH2, and that's it. Getting carried away. So I've got CH2 and another CH2, and then finally at this end I've got a CH3. I've got a CH3. That is my structural formula. Right, empirical formula is, do you know when you've done ratios in school, all they're saying to you, look at these two numbers. Is there a common divisor? Can I divide these two by anything? Can I simplify it? So if I know they're both in the 2 times table. So if I divide them both by 2, I end up with C2H5. So it's the ratio of the molecules in its simplest form. So the empirical formula for that becomes that. And you need to know them for it's, well, good to know though, if you want get good grades and become doctor. Anyway, let's move on. What is the name of this polymerization? Where are we now? Oh no, I've not finished yet. Right, we know the molecular formula of decane, so it'll be C10. Because it's an alkane, I'm gonna double this 10 and add 2, so it'll be 22. Okay. Polymerization, right? Okay, that's fine. Right, let's see, it's too dark in it. Right, let's crack on. VCD. Right, okay. So you've got what you've got is, can you see you've got a double bond here? So it will be an alkene. Remember, two E's, double bond. Right, the general formula is CnH2n. This is the easy one. Right, you add this alkene and another alkene and another alkene, and you end up with one big long polymer. So these are monomers, and they add together to become a polymer. Right, just remember this. If you're adding lots of monomers and you only end up with one product, in this case one long polymer, it's called an addition polymerization. So what's the name of this polymerization? It's called addition. Alright, use the diagram to state two changes. Right, okay. The double carbon, oh my god, carbon to carbon bond breaks. Many monomers, in this case ethene, join together to form a long chain polymer. Right, this is a standard answer. Very, 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 very standard answer. Right, one. There's a higher demand for smaller chain hydrocarbons. Number two, right, there's an oversupply of long chain hydrocarbons. Cracking produces smaller chain hydrocarbons or molecules, yeah. These molecules are used for gasoline. In the UK we call it petrol, and you have it produces alkenes, which are used to make or manufacture plastic and alcohol. Nope, not the one that you can drink. Alcohol, plastic and alcohol. What else would there be? Right, okay, also, right, the burn, right, the mark scheme also says small chain hydrocarbons burn cleaner. I wonder if you can use that. I don't know. I've seen that before. Burn cleaner. They are less polluting. Right, let's move on. Right. Process 1. You're taking crude oil and making it smaller pieces. It's called catalytic cracking. Why is it called catalytic cracking? You use a catalyst called... Have we done this before? Okay. Alumina and silica. Right, watch this. Let's just take a little breather. I'm having a cracking time playing cricket on a sandy beach, and somebody bowls to me with a light, really light metal ball, and when they bowl to me, I hit it for 6 runs. Done. Right, that's how I remember it. And then what I do is I say, right, okay, sand, silica is one catalyst. Light metal, I know is aluminium, so I remember alumina, not aluminium, but alumina. Silicon dioxide, aluminium oxide. Right, remember it's aluminium, not aluminum, as our friends across the pond say. But that aside, and when they hit it for 6 runs, I remember 600 degrees Celsius. Right. Right, this is, do you know something? You're just gonna have to get used to these weird questions. I've noticed, as a non-expert, the questions are getting weirder. And having weird questions is a good thing, really, because it makes you think. Right, we need to describe the difference between crude oil, kerosene, size of molecule, bonding, and viscosities. Viscous is the runniness of a liquid, or how, for want of a better word, how thick it is, how runny it is. Okay, what you do is, first of all, crude oil has large molecules. When crude oil has large molecules, we know crudes had larger molecules, right? So they have, because they've got larger molecules, they have more. Okay, crude oil has nope. Crude oil has more covalent bonds. The different strengths as well. Right, crude oil has higher viscosity. It'll be really thick and runny. Whilst the further up you get, the smaller they get, the less viscous they become, and then eventually become gases at room temperature. Right, what you need to do with this sort of question, just add a few other facts. Just say crude oil is darker in color. Crude oil burns. Crude oil burns. Oh my goodness me, come on. Burns with smokier flame. A smokier flame. So it's got impurities in. Yeah, okay. Just add a few things, it's not going to kill you. Right, this is just simply, it's more of a maths question really, look. So can you see this here? So these are the reactants as such, and these are the products. Right. Deduce. Figure out from what you've been given using the information given in your brain the formula for this. So look, we've got 5 carbons here. We've got 2 times 2, which is 4 carbons here. So we've got 9 carbons, so we need to balance it out. So C9. Now we look at, we've got 12 hydrogens. 4 times 2 is 8. So we've got H20. Okay, there you go. So give the name of the compound, right? Remember we said monkeys eat peanut butter, right? Methane, ethane, propane, butane. Do you know? I blame my students. They keep calling this pentane, and now that's stuck in my head. Methane, ethane, whatever, pentane, and then butane. Right, okay, now listen carefully. The rest is easy. What's a 5-sided shape? Pentagon, isn't it? So it'll be pentane. 6-sided is a hexagon, so it'll be hexane. Heptane, octane, nonane, and decane. We came across that in the question up there. Right, give the name of, so it's got 5 carbons and it's got, instead of 10 hydrogen, it's got 12, so that means it's an alkane. So it'll be pent and then ane. So now we need to draw the, right, this is super important. This comes up so much. So it'll be eth, right? But it's got a double bond because if you double the number of carbons, 2 times 2 is 4. That's it. So it makes an alkene. So it will be ethene. So we're dealing with ethene, and this comes up so much. Right. 2 carbons. So I've just drawn these 2 carbons, and I need to draw 4 hydrogens. So I'll just simply draw 1 on each. Do not miss the hydrogens out because you will no doubt lose a mark. Right. The structural formula of chloro, that means it's got chlorine in. What's going on? Is formed in processes CH2 double bond CHCl. Right. There's a lot going on here. The polymer formed in a process for is called chloroethene, polychloroethene. Draw displayed formula for the repeat unit, not for polychloroethene, but for the repeat unit. Right, now watch this. So you've got, I'm drawing that first. I'm drawing, right, they're not asking for the monomer, they're asking for the repeat unit. So, right, let me just draw it as it is. Double bond, carbon, hydrogen, chlorine. You can put chlorine either side. Because they've asked for the repeat unit, what you do is you rub one of these out. Let's get rid of that. One of the double bonds. And then you stick a bond there and a bond there. So, do you agree? Each carbon atom has got 1, 2, 3, 4. And this carbon atom shares this, it'll be 1, 2, 3, 4. Right. If you ever get stuck on this sort of question, do you know what I tend to do is I tend to draw these brackets in, make sure the lines cross, and then you stick an end there. There you go. Right, polychloroethene is formed by addition polymerization. So look, there's two types. Well, there's lots of types, but addition polymerization, where you only get one product. Condensation polymerization is where you get more than one product, or yeah, just leave it like that, more than one product. Normally you get a little molecule that's lost, so it's condensed. Oh, how do we answer that? A small molecule is lost, or you can say more than one product is formed. Now what we're going to do is, let's finish this here for this video. Right, why does this feel like hydrocarbons? Right, I'll crack on. Polychloroethene and nylon do not biodegrade. You've got to know what this word means. It means when bacteria or microorganisms cannot break down the polymer. Right, okay, what feature of addition polymerizations make it difficult? Just say that they are inert. They are inert. Put the word bacteria and breakdown. Right, okay, we'll do the next in the other videos. Stop that.